welcome to Startup Hack. Today we are going to talk about enumeration in .NET. So let's jump right in. Make sure to check out the link down below because we always provide the code samples that you can pull down and follow along so you can see in our project. Do you want to earn $100,000 a year? Do you want to become a software developer within just 3 months? With our amazing course and awesome tutors, you never have to worry about getting stuck. We help students to learn skills that companies want to hire. We are Startup Hack. Don't forget to subscribe our channel. So let's get started. All .NET developers know and use IEnumerable, but when reviewing code, I have found that many fall into the same pitfall, resulting in applications with easily avoidable performance issues. IEnumerable is very useful and hard to avoid. So in this video, I will explore some of its nuances so you can make a better use of its feature. So enumerating. This is the simplest way to use a for each loop. Let's start with a simple method that takes an IEnumerable int and outputs all its items to the console. So here's an example. You can check at sharp left that in reality this code is expanded to a while loop. Here's the example. Focusing on the enumeration, we can resume it to this. So here's example. Notice that first a new instance of an IEnumerator is created. Next, it starts a while loop calling MoveNext, stopping when false is returned. When it's true, the current property returns the new value. The generic version of IEnumerable implements IDisposable, so the using keyword is used to take care of that. This is very simple, but let's now focus on the nuances. Count versus any. It's good practice to validate arguments and avoid unnecessary computation, so I have found this following very often. It uses the count extension method to check if the enumerable is empty and exists early. Unfortunately, this does way more computation than most expect. From the highlighted points on the enumeration interfaces, we already know that these can only enumerate sequentially and have no more information on the collection. Count implementation looks something like this. Notice that it has to enumerate all the items, counting the numbers of times MoveNext returns true. As a consequence, count has a complexity of O(n). This means the previous code is enumerating the collection 3 times. First to check if it's empty, second to calculate the sum, and third to get the number of items. There's a better solution. Any is an extension method that returns true if the enumerable contains at least one element, otherwise false. Any implementation looks something like this. Notice that it creates an instance of IEnumerator that and then calls MoveNext only once. There's no loop. Any has a complexity of O(1). So you should always use any to check if an enumerable is empty. Usually you don't even need to check if it's empty. The for each doesn't enter the loop in that case. Here's implementation of an average that creates one single instance of IEnumerator and enumerates the collection of only once. So here's example. If required, always use any to find if an enumerable contains any element. Okay, now count versus count. Sometimes finding an enumerable is empty is not enough. You may need to get the actual number of items. Count is an extension method for the IEnumerable interface, while count is a property of the IRead-only collection interface. When using them, the only noticeable difference is the existence or absence of the parenthesis, but their behavior is very different. IRead-only collection is implemented by most collections in the .NET framework. These keeps the count value as a private field or can easily calculate it from other private fields, allowing count to have a complexity of O(1). IRead-only collection derives from the IEnumerable and just adds the count read-only property. IRead-only list and IRead-only dictionary both derive from IRead-only collection and add random access. If you return one of these instead of the usual IEnumerable, the callers will be able to both enumerate and efficiently perform other supported operations while maintaining immutability. You can return other collection interfaces or types if required. You can add one more average extension method for IRead-only collection that takes advantage of availability of the count property and guaranteeing that the method will not mutate the collection. It improves performance by not creating the instance of IEnumerator and not calling MoveNext when the collection is empty. So here's example. The implementation of myRange fills a list with all the range values and then returns it. This is inefficient and it's an issue as it can fill up memory. The solution is to use the yield keyword. In this case, the compiler automatically generates an implementation of IEnumerable that enumerates the values without allocating a collection in memory. In this code example, the method validates the argument count and throws an exception if it's less than 0. You would expect it to be thrown immediately after the method is called. It doesn't. It only throws after the first call to move next. To have the intended behavior, we need to split the method into two parts: immediate for validation, lazy for enumeration. This can be done using a local function. So here's example. Lazy evolution is the ability to only execute code when needed and only as many times as required, regardless of where in the execution pipeline the code sits. You should take advantage of this to minimize resource usage when generating enumerables. So here's example. Alright, composition. I have found way too often the use of toList or toArray when developers want to reuse the result of a LINQ expression. So here's example. This result is unnecessary allocation and copying of all enumeration values into it. This results in a big performance penalty. You should only use these methods when it's strictly necessary to cache the values and it's guaranteed that they always fits in the memory. LINQ expressions can be reused, maintaining the lazy evolution behavior. So here's example. Use composition to reuse expression, maintaining lazy evolution. Okay, now null versus enumerable.empty. I have seen many instances where developers return null when they really mean that is empty. It's important to understand that these have two very different meanings. Null in an invalid state where the IEnumerable instance hasn't been created, empty a valid state where the enumeration contains no values. Returning null breaks the use of the for each and method composition. So you must return an empty enumeration. The system.linQ namespace contains a IEnumerable.empty static method that returns exactly that, an IEnumerable implementation that generates IEnumerator implementations where the method MoveNext always return false. So here's an example of how to use it. When using yield, you can exit the enumeration using yield break, and if no value has returned until then, it results in an empty enumeration. So here's an example for empty enumeration. Never return a null enumerable, use enumerable empty or yield break instead. Alright, IEnumerable. The system.linq's namespace, also known as linQ to objects, contains many extension methods for IEnumerable. Not having random access enumeration support means that full scans are required to find elements and that memory allocations with value copies are required in operations like ordering or grouping. Databases have engines optimized for these operations and support much larger amounts of data. IEnumerable is an enumeration interface that converts the LINQ expression tree into something equivalent that a database can process. The execution of the query is delegated to the database. IEnumerable derives from IEnumerable, so the result can be enumerated just like we have been doing until now. The .NET drivers for database usually support IEnumerable. So Entity Framework is an object relational model wrapping (ORM) that includes LINQ to SQL, meaning it supports LINQ queries on an SQL database engine. So this example based on database model defined in LINQ to query the blocks property that is of type dbSetBlock. dbSetT implements the IEnumerable interface, which in this case converts the LINQ expression to tree to SQL. The toSQL method used on here returns the generated string that will be sent to the database. So this example generates this following. Notice that it's equivalent to the link you query defined in the code. This means it will be fully performed by the database engine. The for each just has to enumerate the result returned. No filtering, projection, ordering, or element counting is performed directly by link queue operations. Now imagine that you want to apply link queue operators to the query result. Don't use toList or toArray. Use IEnumerable instead. It will keep the lazy evolution without memory usage. This example performs a projection on results, formatting the string that will be written onto the console. This is particularly useful with NoSQL databases as they usually support a limited set of operations defined in LINQ. You should still design the data model to execute the query as much as possible by the database engine. Thank you for watching this video. I hope you learned how to use enumeration in .NET. So don't forget to subscribe our channel and hit the bell icon for latest updates. To joining our course, you can simply go to our website called startuphack.com. Thank you.